for Physics 2211. So the goal of this lab is to find the mass of the black hole, and we can do this using Newton's second law, which states that the net force is equal to the change in momentum over the change in time. So we run a computational model to solve for the mass of the black hole for us. So you can see here, a star is on a trajectory around the black hole, and you can see the different arrows with the different components of the forces. So first, to solve for our trajectory, we want to input our email, and the code will output our trajectory. Then first, we're going to define our gravitational constant, which we know as 6.7 times 10 to the negative 11th, and we want to state our mass of our star, which is given, which is 2 times 10 to the 30th kilograms, and our change in time, which is 86,400 seconds, or 1 day. Next, we want to solve for our y component, position and velocity, and our x component, position and velocity. So we know that our change in displacement is the final minus the initial, and we know our velocity is the change in displacement of the change in time. Then we want to run a while loop. So first, we input our initial and final velocities in vector form, as well as our initial and final momentum, which we know momentum is equal to the mass times the velocity, and we're just using respectively the initial velocity and the final velocity. Secondly, we want to find the change in velocity and the change in momentum, and we know that the changes in each of these is the final minus the initial, which we have written above. Next, we want to find the change in momentum over the change in time. So we're just defining it in that line, and then we are stating that the net force is equal to the change in momentum over the change in time, and we know this by Newton's second law. So we want to break down our force into these components. So the net force is equal to the parallel and perpendicular. So we use our unit vector, our magnitude of our change in momentum over change in time, and use those two to solve for the parallel component of the change in momentum over the change in time, and we can set this equal to the net force for the parallel direction. And we know that the net force in the parallel direction acts on the velocity. So secondly, we want to find the perpendicular component of the change in momentum over change in time and the perpendicular component of the net force. So we can do this because we know that the change in momentum with the change in time is equal to the parallel plus the perpendicular components together, as well as the net force. However, the net force is a combination of the parallel and perpendicular components, and that gives us the magnitude, while the change in momentum over the change in velocity is the object's motion, which can be broken down into these two components. Secondly, we want to find the radius of the Kissing circle, we just know as the origin of our position of our black hole and minus the position of the star. Next, we want to solve for the mass of the black hole, which is the point of this lab. So we know that the total net force is equal to the gravitational force, which is given by the gravitational constant times the mass of the star and the mass of the black hole over the radius of the Kissing circle squared. So we can rearrange to solve for the mass of the black hole, which we input into our code. Next, we want to just adjust the arrows so that they follow along with the net force, the parallel, and the perpendicular components. So here we have our final trajectory. You can see the different components in the arrows. So our mass of our black hole is equal to 8.5 times 10 to the 33 kilograms, and our net force is equal to 8.25 times 10 to the 28th newtons, and you can see the parallel and perpendicular components broken down. So if we were to have a different mass, we would never be able to achieve the same trajectory if everything stayed the same, because the net force would be different, and therefore our radius would be different. However, if we wanted to keep the trajectory the same and keep the and change the mass of the black hole, then we would have to change the mass of the star to achieve this result. Otherwise, it is not possible.